uh, read the question carefully first. Read it and try to figure out, draw that diagram and try to figure out which side of the tail you are looking at. Are you looking at the left tail or the right tail, or you are looking at both tails? That information you will get from the question itself. Second thing, once you read the question, then you see what are the informations you are given. You will always be given these information in your question. Remember this M, what is it? It's a sample mean. You will always be given mu, that is the population mean. You will always be given n, lowercase n, that means the size of the sample, and you will always be given the standard deviation from this population or the sample. This information you will always be given, and you will utilize these to calculate your z-score. When we are saying the test statistic, if you look at this handout, once you write down, okay, let me backtrack. So you read the question, then you see what are these information given to you in that question. It's always given to you. Then once you read that question, first thing, as I mentioned here, write down your alternate hypothesis first, like H sub 1 or H sub A. Write down that alternate hypothesis first and then write your null hypothesis. Always do that. And you write that alternate hypothesis based on the information given to you. So that's why you need to write that H sub 1 first and then you write H sub 0. Once you are done with that, second step, you calculate the test statistic, which is the z-score. And you know the formula for z-score, and all these numbers given to you, you will be using it in this formula. So z equal m minus mu divided by standard deviation divided by square root of n. This is the formula. So you calculate this test statistic, the z-score, and then you look at the value of alpha, whether it is 0.05 or 0.01. Most of the cases, we rarely use 0.001. And then look at your alternate hypothesis and you will know which tail you are looking at. If your alternate hypothesis has this sign, then you will be looking at the right tail. If your alternate hypothesis has this sign, then you will be looking at the left tail. If your alternate hypothesis has not equal to sign, then you will be looking at both tails. So that's why I keep saying you need to write your alternate hypothesis first based on the information given to you. So remember these. If it is bigger than sign, look at the right tail. Because the values, remember, in normal curve, the values they go higher, more to the right. The values get lower to the left. So if you have the less than sign, then you look at the left tail. And if you have not equal to, then you will be dividing that alpha into 2 equal halves. Look at both tails. Are you guys with me so far? Okay. So look at this. Look at the alpha, value of alpha, look at which side, which tail you are going to look at, and then you decide your rejection region. And then look at the z value at this point, and then based on that you decide whether you are going to reject the null hypothesis or not. So let's look at this example. what I did here, first page, we are going to look at a one-tailed hypothesis test. And we are going to look at the right tail. Second page, we are going to look at, again, one-tailed hypothesis test, but we are going to look at the left tail. And the third page, it's a two-tail. So let's start looking at the first one. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,800. They are concerned that the true average or the true mean is actually higher than $1,800 because they could potentially lose a lot of money. So they randomly selected 40 claims. See, these 40 claims, that's your N, that's the sample size. The population mean given to you is 1,800. And from this randomly selected sample of 40 claims, they calculated the sample mean, which is the M, and they found it as $1,950. Now, assuming that the standard deviation of these claims is 500 and alpha equal 0.05, we need to find out if the insurance company should be concerned, meaning they need to change the policy or not. Because when they did their sample, the sample mean came out much higher than the population mean. So should they be concerned or not? This is the information you are given. So if you look at this information, your M, the sample mean, is much higher than the population mean, right? Sample mean is 1950, population mean 1800. Because of that, your alternate hypothesis will be mu greater than 1800. Are you guys confused at this stage? So your H alternate hypothesis or H sub 1 will be mu more than 1800. So more than 1800